We've zeroed in on the location where our sensors show new minerals are forming as we speak. Let's take a closer look. We've landed on the bright white, wide and windy plains just outside of Judd, Oklahoma. This is the Great Salt Plains National Wildlife Refuge. Why is the land here so flat? Why isn't anything growing here next to the lake? And why is everything so blindingly bright? We notice some visitors in the distance, and it looks like they're digging. Well, let's grab our sunglasses and a shovel and see what clues we can find hiding below the surface. Using the shovel, we break through the crispy white layer on the surface and see reddish-brown sands and clays within the hole. As we dig, we can hear something crunching and breaking within the ground. We only need to go about a foot down, so this should be good. Looking around, we see people scattered about randomly, digging holes. There must be something valuable down there. The weather at the Salt Plains today is windy, warm, and dry. Scans show that the water is rapidly evaporating from the nearby lake. Evaporation would cause any minerals dissolved in the water to become really concentrated. As the total amount of water goes down due to evaporation, the proportion of dissolved minerals in the remaining water goes up. Looking closely at the ground, we observe tiny bits of mineral crystals. All of the crystals are clear or whitish, but we can see some clues indicating there might be more than one type of mineral down there. First, we see some hard, rounded crystals. These are quartz grains. The roundness tells us that they were transported here from elsewhere, and their sharp edges were all broken off during the trip. We also see some familiar salty crystals. These are halite, or rock salt. They're all still cube-shaped and pointy, so they must have formed really close by. This last one is tricky. It's a soft mineral, but the crystals are still pointy. Unlike the halite crystals, we don't really see a crystal shape though. Instead, these look like angular, broken fragments. We're gonna need some more data to figure this one out. As we reach down into the water in the hole and feel along the sides and the bottom, we find a crystal. It has a bladed shape and pointy ends. This must be what everybody's digging for. Scanning the crystals shows that this is the mineral selenite, which is a form of gypsum. This is the same mineral that we see at the surface here, along with quartz and halite. The bladed shape is how selenite crystals will naturally grow, but it's the interior of this crystal that's really interesting. Most of the crystal is clear, except for the hourglass shape in the center. The hourglass is formed when sands, silts, and clays get trapped in the selenite crystal as they grow. These special crystals are called hourglass selenite, and they're Oklahoma's state crystal. Selenite is a type of chemical sedimentary rock called an evaporite. Evaporites form from water that has a lot of mineral components dissolved in it. When this enriched water evaporates, the components become even more concentrated. Eventually, components begin linking up and crystals precipitate and grow.